Get ready to blow your mind with some major geological news. Earth's continents are about to go through a transformation. You might recall Pangaea, the supercontinent where all landmasses were once connected. Well, that was millions of years ago. Plate tectonics caused it to break apart into distinct sections, giving us our current map. Now, Africa's surprising split could completely redefine how we perceive our world. Stay tuned as we dive into what's happening and the far-reaching effects this change might bring. But first, let's take a trip down memory lane. Our planet Earth formed from a cosmic cloud of gas and dust roughly 4.6 billion years ago, initially molten due to extreme heat. As it cooled off, something incredible began to take shape. Earth's explosive start. Imagine a cosmic game of bumper cars, only instead of cars, we're talking massive space rocks crashing into each other. Our planet was basically one giant, molten mess with extreme temperatures and intense pressure. But amidst all that chaos, something amazing started to form. Around 4 billion years ago, lighter elements began floating up like magic, creating the first pieces of continental crust. These early building blocks were destined for a major transformation in the future. Fast forward to when these initial chunks started to bump into each other, forming new land masses through volcanic eruptions, layer upon layer of sediment, and the Earth's crust gradually cooling down. This slow dance led to the creation of smaller continents. Over time, these continents began to move, collide, and merge due to plate tectonics, a massive game of cosmic dominoes. Around 1.6 billion years ago, the supercontinent Rodinia took shape as landmasses collided and fused together in an epic display of Earth's geological might. Rodinia eventually broke apart and reformed multiple times before making way for Pangaea. And it's from the continents that emerged after Pangaea's breakup that our modern-day continents are made up. Let's dive into how our world came to look as it does today. Approximately 335 million years back, all landmasses merged into one giant supercontinent known as Pangaea, where Africa, Antarctica, Asia, Australia, Europe, North America, and South America were once a single massive land unit. But over millions of years, Pangaea began its gradual breakup due to the Earth's tectonic plates continuously moving, a phenomenon we know today as continental drift. As these plates shifted and changed, they contributed significantly to the formation and rearrangement of our continents. Now, let's throw it back even further. During Earth's early days, our planet experienced multiple collisions with large space rocks, like asteroids and comets, which played a crucial role in shaping its surface. These celestial crashes helped form new landmasses and continue influencing Earth's geography to this day. Imagine the Earth being hit with an enormous force that's beyond our imagination, a colossal meteorite slamming into its surface. As this massive object crashes onto our planet, it unleashes a gigantic amount of energy, transferring immense heat and pressure deep within the Earth's crust. This tremendous impact can trigger volcanic activity by heating rocks to their melting point, turning them into molten magma. With temperatures soaring, the magma rises from beneath the Earth, resulting in breathtaking volcanic eruptions that shape our planet's landscape. These spectacular displays are more than just awe-inspiring events. They play a pivotal role in shaping our world and contributing to the formation of new landmasses. The action doesn't stop after that colossal impact, it's just getting started. The newly formed land masses are now molded by a series of powerful geological forces. Erosion, a force of nature where wind and water patiently yet persistently chip away at our landscapes, helps to carve out valleys, create canyons, and sculpt mountains. Meanwhile, sedimentation brings together tiny particles swept away by erosion and deposits them in new places, laying the groundwork for future rock formations. As continents continue their journey across Earth's surface, tectonic movements push and pull these landmasses apart or collide with one another, reshaping coastlines, creating mountain ranges, and even forming deep ocean trenches. Over billions of years, this intricate dance between geological forces has sculpted the diverse and ever-changing landscapes we see today. Let's set the scene. Earth's epic story is written in stone, literally. The dynamic dance of tectonic plates has been a game-changer for our planet. But what's even more mind-blowing is how these constant movements played a crucial role in creating the stability we see on Earth's surface today. It's almost ironic that this seemingly unstable process was actually a key contributor to a calm and peaceful environment, at least when it comes to our planet's physical features. But here's where things get really interesting. As tectonic plates kept moving, they weren't alone in the changes taking place on Earth. The atmosphere underwent an incredible transformation too. In its early days, Earth's atmosphere was a toxic nightmare with volcanic gases galore and virtually no oxygen to breathe, a far cry from what we enjoy today. It wasn't until early life forms like plants came onto the scene that things started shifting. Through photosynthesis, they began converting carbon dioxide into oxygen, slowly but surely transforming our atmosphere into the perfect blend for life as we know it. And that's when natural wonders like erosion and sedimentation kicked in, helping to stabilize Earth's surface features over millions of years, giving us the beautiful landscapes we see today. Get ready for an epic tale that'll rewrite your understanding of Earth's ever-changing landscape. Life on our home planet wasn't just about diversity and survival, it also played a massive role in stabilizing the very ground we walk on. As the dynamic dance of tectonic plates continued, erosion, with its relentless wear and tear on mountains and landforms, began to reshape Earth's surface, redistributing material left and right. Simultaneously, sedimentation started building new land masses, creating fertile grounds for life to thrive while stabilizing our coastlines. But here's the fascinating part: life itself became a major player in this cosmic ballad. Plants, with their deep roots and steady growth, anchored soil and prevented erosion from taking over. And through photosynthesis, they subtly yet significantly altered Earth's atmospheric composition, making it more hospitable for us all. Now, let's fast forward to an extraordinary event happening beneath the arid expanse of East Africa's Afar region. A monumental transformation is unfolding in near silence. Buckle up for one of Earth's most incredible real-time transformations. You're standing at the triple junction of three tectonic giants: Africa, Arabia, and Somalia. Here, these continental titans are in a slow-motion dance, pulled apart by forces so powerful they'll eventually change our planet's face forever. This is East Africa's Afar region, where the land itself is being ripped asunder, giving birth to an awe-inspiring rift valley, and this 35-mile-long crack we're talking about. It's just the surface tip of a massive geological iceberg. Scientists predict that in millions of years, these plates will continue their relentless march apart, potentially forming a brand new ocean basin where land now stretches. This isn't a one-off event, it's part of Earth's grand plate tectonics show: continents drifting, oceans forming and disappearing over ages we can hardly fathom. In one of the most electrifying geology labs our planet has to offer, Africa's east coast, we're witnessing history being written with each passing day. Here, satellite technology is revolutionizing our grasp of an ancient prophecy: two continents splitting apart and a new ocean rising from the chasm left behind. A team led by PhD researcher Christopher Moore at Leeds University is using cutting-edge satellite radar to monitor volcanic activity in this remarkable setting. As the African continent slowly tears away from its neighbors, East Africa's Afar region stands as our world's sole active laboratory for observing how a continental rift evolves into an oceanic one, a natural spectacle of unparalleled scientific value. Here, on the vibrant canvas of Africa's eastern frontier, an epic tale of tectonic separation unfolds, etching its mark across millions of years. Beginning with the Arabian Plate's steady drift away from the African landmass about 30 million years back, we find ourselves witnessing the birth of two majestic water bodies: the Red Sea and the Gulf of Aden. Concurrently, in a fascinating display of geological dynamics, the Somali Plate has started to move apart from the Nubian Plate along the East African Rift Valley, a breathtaking journey that traverses through Ethiopia and Kenya. Yet, despite the immense scientific exploration into this phenomenon, there are still crucial questions lingering about the continent's divergence, leaving us eager for further discovery. Let's dive into a mind-blowing theory that's revolutionizing our understanding of Africa's tectonic tale. Scientists propose that it's not an asteroid impact, but rather an extraordinary upsurge from within Earth itself. A superheated plume of molten rock rising from deep beneath the African continent could be the key driver behind this continental rift. Unlike during the Earth's initial formation, when massive asteroid impacts played a role in shaping our continents, this time it seems we have to look inward for answers, straight into the heart of Africa's mantle. As geophysical data reveals, what appears to be an African superswell, or a hotter-than-normal region of mantle material, is believed by some to be behind the birth of the Rift Valley. As we unravel this gripping tale of a rising mantle plume beneath Africa, let's not forget its profound impact on both land and sea. This incredible force is not only responsible for shaping the African continent as we know it today, but also predicts a dramatic transformation in our future. The African superswell theory suggests that this superheated upsurge could lead to the splitting of our beloved continent into two separate landmasses, each with its own distinct features and coastlines. This seismic shift would, in turn, significantly alter oceanic currents and weather patterns, bringing about changes in regional climates. And as the African plateaus start to drift apart, a heightened risk of earthquakes and volcanic eruptions looms over communities living within the rift zone. As we've explored this groundbreaking theory that Africa's continent could potentially break apart, one of the most striking aspects is how humanity might adapt to these colossal changes. Although the African superswell process is predicted to take around 5–10 million years, that's still an unfathomably short time for our planet's geological history. The regions directly within the rift zone are at risk of disappearing forever, forcing residents into a life-altering migration. But the real question is, if this phenomenon can occur in Africa, what prevents it from happening elsewhere? Could we soon see smaller, fragmented sections of our once vast continents emerging worldwide? Share your thoughts on this mind-boggling idea in the comments below. If you found this video as captivating as I do, don't forget to give it a thumbs up and hit that subscribe button for more awe-inspiring videos about our ever-changing planet. Can't wait to dive into another fascinating topic with all of you. Stay curious and keep exploring, because there's so much more to discover about this incredible world we call home. See you in the next video.